Hello students, how are you all? Fine? Good. Okay. So you are going to discuss some problems here. Okay. So let's start. Our first problem is a 10-meter wire is kept in east to west direction. So this is a 10-meter wire and this is west and this is east direction. Okay. Now it is falling down with a speed of 5 meter per second. Suppose this is a downward direction and it falls down like 5 meter per second. This is the speed. Okay, some distance. Suppose this is the ground here. Okay, so suppose this is a distance, whatever. At this moment or at this point, the speed of the wire is 5 meter per second. As we know that due to gravity, it's accelerate for free fall. That means every moment or every point, its velocity can changes. So in the problem, so 5 meter per second, suppose at a instant or at a point, the velocity is 5 meter per second. Okay. Now, the perpendicular to the horizontal component of the earth magnetic field of 0.30 into 10 to the power minus 4 Weber per meter square. This is the component of earth magnetic field, that is horizontal component. Okay. The momentary potential difference induced between the ends of the wire will be option A 0.0015 volt, option B 0.015 volt and option C 0.15 volt, option D 1.5 volt. So our here question is the momentary potential difference induced between the wire, between the ends of the wire. So what is momentary potential difference? What is momentary? That this term is very important. That momentary means that is temporary or like instant potential difference, because whenever it goes down, all the time the velocity will changes. So every moment the induced EMF will changes. So at this moment, whenever its velocity is 5 meter per second, at that instant, what is the potential difference induced? Okay, that means at this instant, what is potential difference means? That is momentary. Okay, at that instant, right? So how can we proceed? So here one term is here, that is perpendicular to the horizontal component of the earth magnetic field. Okay, so as we know that earth is a big magnet. Okay, suppose this is our earth and this is a magnet. It has north pole and south pole. Okay, so earth's magnetic field like a bar magnet. Okay, suppose this is north pole to south pole. This is the lines of force here. Okay, right, like this. Okay, so now this component, suppose at this point, this is the direction of magnetic field, that is B. So it has two component, like this is horizontal component like BH and B V, that is vertical component here. Okay, this is theta angle say. Okay, so this is the this value is given here, that is 0.30 into 10 to the power minus 4 Weber per meter square, that is magnetic field horizontal component, right? Okay, so basically a wire, that is conducting wire, is moving in a magnetic field. And as we know that whenever a conducting wire moving in a magnetic field, the flux is changes and a induced EMF is generated. So we have to calculate that EMF or potential difference. Okay, so let's proceed. So like okay, suppose this is direction of, take earth direction. Suppose this is the horizontal direction. Okay, say this is the left hand rule we can apply here. Suppose this is the the middle finger is the direction of magnetic field, that is north to south. This is the horizontal component, like this. This is the marker here towards you. Okay, and this direction, the motion or speed direction, like this is the velocity direction v towards downward. So this is the thrust on the free electrons in the conductor. Okay, so whenever, why this induced EMF generated? Because whenever this conductor is moving in a magnetic field, conductor have many electrons are there, that is free electrons. Whenever it moves in a magnetic field, it can get a force. Okay, why? Because from framing left hand rule, this is the direction of, suppose this is the magnetic field direction that is out of the page or out of the board here, and this is the motion here, that is v. So that means this is magnetic field direction, this is motion direction, they are mutually perpendicular. Then we can get the thrust, that means the force on the free electron, that is electrons, towards say east. Okay, so that's why these electrons are moving this side, that is east side. Okay, now इसके बाद क्या होगा कि ये जो इलेक्ट्रॉन जब एक वन साइड में चला जाता है तो क्या होता है, this side will be positive and this side will be negative. That means a electric field generated over here, because as we know that electric field direction is from positive to negative. Whenever charge accumulated here, this is negative side and this side is positive, the electric field generated from positive to negative. That's why whenever electrons moving or gets force towards this direction, and due to electric field, it is, it can get force, that is, this force name is Coulomb force, that is q into E. Suppose this is the charge of electron, that is q into E. So whenever these two forces are balanced, that means this force, what is this force? The right hand side force. This force due to what? Due to induced EMF. That means as we know that the force, that is Lorentz force, you know, whenever a charge moves in a magnetic field with velocity v, that is q into v cross b here. Okay, so whenever v and b are mutually perpendicular, that means q v b sin theta, sin 90 degree here, that means q v b. This is the force, that is Lorentz force on this charge, and this side due to production of electric field, that is q into E. Whenever a charge in an electric field, the force क्या होता है, q into E. So whenever these two forces are in balance, that means q into E must be equals to q v b. So electric field value is v into b. And what is the length of this wire? That is say L, that means 10 meter. That means the potential difference must be V equals to E into L. That means E value is Vb and L is here L. So this is our momentary potential difference, that is induced EMF say, or potential difference, that is VBL. Clear? Just put the all the values given here in this equation and you can get the answer. Okay, so that is V equals to, V means here that is 5 into B is 0.30 into 10 to the power, okay, 10 to the power minus 4 into, and L means 10 meter. Okay, so just put here and just calculate it, that is 5 is the 15 and this is 10 to the power minus 4 and 10 minus 3, that means this point is here like this, 1 2 3 like this. This is our answer, this volt. Okay, all are in SI unit, so that is voltage potential difference will be in volt. So that is 0.0015, it is our answer. So option A is here. Clear? Okay, let's go to our next question. Okay, so this is our second question here. In a circuit shown in figure, the 5 ohm resistance develops 20 calorie per second. So this is a 5 ohm resistance. It develops 20 calorie per second due to the current flowing through it. So some current flowing through this. Okay. So this is the heat generated here. So the heat developed in 2 ohm resistance. The heat developed in 2 ohm resistance here is. सो ये 2 ओम में क्या कितना हीट जनरेटेड होगा या प्रोड्यूस होगा वो कैलकुलेट करने के लिए कह रहा है. सो ऑप्शन ए इज 23.8, ऑप्शन बी 14.2, ऑप्शन सी 11.9 एंड इन ऑप्शन डी 7.1. all are in the unit of calorie per second. Okay, so basically as we know that whenever a current passing through a resistance, okay, due to this current is passing through this resistance, so it produces some heat in the form of joule heat. Okay, this is joule heat, and we know the expression of joule heat, that means I square R into T, where I is the current flowing through this is the current, and R is the value of the resistance, and T is the time. Okay, जितना टाइम जाएगा तो उतना हीट प्रोड्यूस होगा. Okay, so heat is proportional to this time also. Okay, but here the unit is given here calorie per second. That means this heat means calorie per second, 20 calorie per second. So as we know that heat is a form of energy. Okay, so it must unit that calorie or in joule. Okay, calorie is the CGS unit, but here given is calorie per second. That means energy by second is the unit of time, that means time. So energy by time, calorie by second, that means power. Okay, energy by time means power. So that means here power is given. Okay, so whenever a current passing through this resistance, that is 5 ohm resistance, the power generated here in the form of heat, that is 20 calorie per second. So you have to calculate the power at 2 ohm resistance. Okay, so basically we have to calculate here, this power is I square into R. This I is flowing here, this is the our current here, and R is the resistance, that is 2 ohm. Okay, so to find I first, because R is given here, just you have to find I. Okay, so how to calculate I? So as we know that this current is branching over here, that is say this is I1, this is I2 current. Okay, and I means I1 plus I2. Okay, this is I means I1 plus I2 here. So you have to calculate I1 first, then I2, and if you sum the all of this, then you can get I. Okay, so first calculate I1. So how can we get? Okay, this power is given here, that means I1 square into R is given 20 calorie per second. Okay, this unit and this unit is same, so you not need to be change any unit here. So I1 means 20 by R and root over. Okay, so 20 and R value is 5, that is 4. Okay, that is 2. Okay, 2 ampere. Say, okay, so this is our current here. Okay, now you have to calculate I2. So how can you get? So say see this resistance and this resistance, suppose these two are in series. Okay, these two are in series. That means this figure, if we read 9 and 6, because in series both resistance are in added, so 9 and 6, that is 15 ohm, and here 5 ohm. Okay, this is C point and this is D point here. So if you see there, that means 15 and 5 both are in parallel. Okay, both are in parallel. That means this voltage, suppose the voltage across 15 and 5 must be same, because in parallel, suppose in parallel जितना भी resistance लगा लो, all माने all in all the resistance voltage across them is same. Okay, in parallel current is branching here. Okay, all the current may not be same here, because suppose this is I1, this is I2, this is I3, but voltage across them must be same. Okay, so say voltage is V across CD, so this voltage across CD must be same. That means voltage means I into R, that means IR, I1 into R1 must be equals to I2 into R2. Okay, from Ohm's law, V equals to IR. So this is I1 current here, this is I2 current here, and these are the resistance, and we know the value of I1, so you must calculate very easily, that is I2. So that is I2 means what is the value of I2? I2 means I1 R1 divided by R2. That means what is the value of I1 here? 2 into, okay, I just write over here, I2 equals to I1 R1 by R2. I2 is given here, that is 2 into R1 is, that is 5, divided by R2 is 6 plus 9, that is 15. That is 2 by 3 ampere, right? Okay. So we got I1 and I2. So we must say I equals to I1 plus I2 here. So I1 means 2 and I2 is 2 by 3. That means the 6, the 8 by 3 ampere. Okay, our calculation is end here, because I, this is 8 by 3 and 2 is given here. So that is power in 2 ohm resistance, that is I square into R, that is 8 by 3 whole square into R means 2. That means what's the value of this? 8 is square, that is 64, and this is 9 and this is 2. So 128 divided by 9, right? So you can just calculate here. Okay, 1 and this is 3 here, so 4, 4.2, that is 14.2 calorie per second, right? 14.2, that means option B is our correct answer. Okay, okay, let's move our next question. Okay, our next question, that is third question here. If the mass shown in figure is slightly displaced, that is, this is our figure. Okay, this is the mass M, slightly displaced and then let go, the system shall oscillate with time period of. Okay, this is the system here. 3 springs are attached in this form, and K be the spring constants. Okay, so this is the K and K all have same spring constant. Okay, so this question is, suppose this mass is attached over here. So if I displace this mass like in upward or downward and let go, then it can oscillate. Suppose for a single spring, you can understand here easily. That is, suppose this is our spring. Okay, this is a spring in normal condition. Okay, and I just attach a mass. If I attach a mass over here, now this spring can stretch. Okay, due to the force, that is mg. Okay, this is the load here, that is mg. Now if I displace this mass slightly, not in a big way, okay, just slightly, suppose if I move in upward or move in downward slightly, this is our position here, suppose x equals to 0, suppose slightly in upward or in downward, okay, slightly if I displace and let go, it can oscillate. Okay, so our question is, for this oscillation, what is the time period of this? Okay, for single spring, suppose this is a k constant here, so you can get the time period 2 pi root over m by k, where m is the, this is the mass, and k is the time sorry, spring constant over here. Okay, okay, so this is the time constant. So you have to calculate time constant for this system. Okay, so this is easy for a single spring, but for this system or many question, there are more complex system over here, over there. So for that you have to calculate from this same formula, but you have to calculate this k for a single spring. This is the spring constant. So for this system you have to calculate first spring constant, that is k equivalent for all over this spring. Okay, this is for single spring, single k is here, but here 3 pins is here, that means k and k. For this system you have to calculate equivalent spring constant. Okay, so how to calculate? As we know that whenever springs are in series or spring are in parallel, say like this, okay, 3 pings are, suppose this is k1, this is k2, this is k3, सब अलग अलग मैं वैल्यू ले रहा हूँ. Suppose this, for this system, what is spring constant? Equivalent spring constant, that is in series equivalent spring constant k equivalent is 1 by k equivalent is 1 by k1 plus 1 by k2. Okay, for third spring like k3, then we can add k3 also. Okay, and so on. Okay, like resistance, whenever we connect resistance in parallel way, we can get like this equation. Okay, for r1, r2, r3, you know. Okay, but here for spring this equation is totally opposite. For series combination we can get this type of equation, and for parallel combination we can get simple, you can get simple k equivalent equals to k1 plus k2 plus k3 like resistance in series. Okay, but in parallel cases we can get this equation. Okay, so firstly this is our theory, but in this problem this system is combination of series and parallel also. Okay, here these two springs, suppose we can say, suppose this 1, 2 and 3, so 2 and 3 spring are in parallel with in their parallel, and this system, suppose 1 and this system are in series. So you have to calculate first this equivalent like this, suppose k equivalent between 2 and 3, that means suppose you can say this is dash, k equivalent dash equals to k plus k, because both are in parallel, that means k and k, that is 2k. So this is k equivalent dash. Now Now this figure is simplified like this. This is K equivalent dash. Okay, both spring are merged in a single spring, and its equivalent or its spring constant is 2K. Okay, now these two, one and the combination of these two springs, say fourth spring, this 1 and 4 are in series. So what is our total spring constant? That is K equivalent. That is, these two are in series, that is K plus, sorry, 1 by K equivalent, in, as we say earlier, that is in series, the combination, the equation is 1 by K plus 1 by K equivalent dash. That is 1 by K, and K equivalent dash means the value of K equivalent dash is 2K. That is 1 by 2K is here. So if you calculate here, that is K equivalent means K into 2K is just 2K into K, that is 2K plus K. So K into 2K, 2K plus K. For simplify, and just you can remember just multiplication of two spring constant divided by summation of two spring constant. Simple here. So that is 2K square divided by 3K. That means 2K by 3. Okay, this is equivalent spring constant here. That means it is converted into a single spring now. Okay, so our calculation part is done. Just one part is remaining, that is time period. Time period means 2 pi root over m by k for this system, that is K equivalent. Okay, this is time period for a single spring. So we converted all the system into a single spring having spring constant is K equivalent. So just put over here. So our calculated time constant was what? 2K by 3. So just put over here. M is same here, that is M, and 2K by 3, that is 2m, 2 pi root over 3m by 2K, right? So this is our answer. So in option B, 2 pi root over 3m by 2K, like this. Okay, so this is all about. Hope you enjoyed this video. Okay, and hope this answered your question. Thank you so much. Thank you.